Ribbit, a new digital text messaging mode for VHF-UHF emergency communications. Thank you for being here. We've got exciting content to share with you, and we think that you're going to love it. In this 20-minute presentation, today's agenda will be highlighting the need, why Ribbit, how we do it, where we'll reveal the secret sauce, where we are going, share the vision, and if you stay until the end, you'll get your own giveaway app, a free tech demo app download code. This 20-minute presentation will be followed by a live Q&A where I will join you to answer any question you may have. What is Ribbit? Ribbit is a novel digital text messaging mode for VHF-UHF communication for recreational and emergency use, which radically increases the density of information transmitted by spectrum use. It leverages the computing power of the modern smartphone to increase the capabilities of any Handy Talkie without requiring any additional hardware. Its redundant distributed nature allows it to function even when the internet connectivity is lost during emergencies. Ribbit is open source and currently in its early stages of development. About me. I'm Pierre Delieu, Ribbit inventor and lead architect. I got my first ham license in 1998 in France as F4CKX while studying physics at university. I rejoined the hobby in 2020 as W4CKX in the US with a focus on emergency communication. I joined the Open Research Institute in 2022 to accelerate Ribbit development. Ribbit is a project of the Open Research Institute. The Open Research Institute is a nonprofit research and development organization which provides all of its work to the general public under the principles of open source and open access to research. Ribbit development team is currently myself, Pierre Delieu, W4CKX, and Ahmet Inan from AICODIX GmbH. If you have some skills that you would like to contribute, get in touch. We'll welcome participation in the project. Why we do it, the need. Cell phone and cellular towers are the default mode of communication for citizens. It provides the fastest connectivity, a superior user experience, and multiple modes of communication like search, web, email, chat, text, phone calls, and video calls, as well as pictures. It is best in class, 99+% of the time, but it's also a single point of failure. And in less than 1% emergency, cellular can go down for weeks. The infrastructure can fail, and large populations are without communications for days and weeks. An example is hurricanes. A study from the FCC shows that about 1,000 cell towers were knocked out during Hurricane Katrina. And more recently, Hurricane Harvey knocked out more than 360 cell towers, which is 75% of Puerto Rico's cellular network. Think about the time it takes to rebuild 1,000 cell tower. It's not a few days, it's weeks and months. Likewise, wildfires, fiber optics cables melt and towers burn, the Kincaid fire and PG&E power shutdown impacted 900 of California's cell sites. They were not operating. And an example in Marin County, 57% of the network was down. And more recently, last year, full cellular restoration in tornado-ravaged Kentucky is expected to take months. In this situation, the amateur radio emergency service operators are on the air to assist communications. This works extremely well for short periods of a few hours to several days. It's much harder to sustain over days and weeks. Maintaining a flow of communication with hundreds of people over a long period of time is challenging. There's a need to overcome operator fatigue, handling numerous concurrent subjects and issues, remembering earlier subjects and issues, issue of memory over time, transcribing everything in writing, transferring context information to the next net control operator, sharing workload among different operators, and communicating exact location of assets or message provenance. VHF/UHF voice mode has limitations. How can we support ARES volunteers? We can provide them with modern text messaging capabilities to work alongside voice communications on the same frequencies and local repeater infrastructure. Text messaging is complementary to voice, real-time tactical awareness of the situation. It's time-stamped and geocoded messages. It brings message history and forward capabilities and requires no additional hardware because it's just an app. Text can do more. The benefits of Ribbit text over VHF/UHF. Again, Ribbit text and regular voice cohabit on the same frequencies. The benefits of Ribbit text messages is a high-level view of all messages, geolocation of every messages, ability to copy-paste, therefore no transcription error, workload sharing across multiple operators, complete history, respond to a message, and it only takes 1 second to transmit. Text does more. How we do it, the implementation. How to use your cell on the VHF/UHF ham bands. Well, even without cellular connectivity, you still maintain capabilities in your smartphone. You have a large screen with a touch interface and keyboard input, high compute power, large memory, and with the receiver GPS inside your cell, you will get exact time and exact location. Finally, you have a speaker and a microphone. And if you take a regular HT, any HT, it gives you UHF/UHF analog transceiver, a voice-activated transmit box mode, which is not required, but it's nice to have, and also a speaker and microphone. And if you look at the lowest common denominator between these two pieces of hardware, we actually are targeting transmission of data through acoustic coupling between the speaker and the microphone, and this requires no hardware and no cable. This is the technical part, how to transmit data reliably via acoustic coupling. And I will share 2 slides. The room around you, where you're going to operate the 2 devices, has multiple paths for the sound to propagate, which causes multiple echo in the microphone. This multipath echo is creating intersymbol interference. To deal with multipath, we use orthogonal frequency division multiplexing, multi-carrier modulation. One drawback is that it gives us a lesser than ideal peak to average power ratio compared to a single carrier system. The workaround is that we leverage quadrature phase shift keying to modulate the carrier and slightly manipulate the amplitude of each carrier to improve PAPR to the point of making the whole system robust and practical. Unlike voice transmission, where noise is without consequences, in a digital transmission, noise is detrimental. Therefore, we use forward error correction code, and more specifically, BCH code for the call sign header, and systematic Pola code for the text payload. Here, I'm going to give you a demo of message transmission of Ribbit. So in the current setup, you can see the phone as an app, and in that app, the microphone is continuously listening for Ribbit messages. Then you will see a message received by the HT, and you will see the message instantly decoded in the app and displayed on the screen. I will play the video recording 2 times. And again. So here we were able to see that a text message can be transmitted extremely fast over acoustic coupling. The benefit of our implementation is that the digital text audio transmission survived the path from the first smartphone through the first HT throughout an analog VHF-UHF transmission with or without analog repeater to a second HT out in audio coupling to the last smartphone number 2. And this can go over an AM modulation, FM modulation, or single sideband. But also it can survive Bluetooth audio compression and transcoding. So that is analog audio converted into the digital Bluetooth and back to analog. It can also survive YouTube audio compression and transcoding. Where we are going, or vision. The look and feel for Ribbit is a blend of different services that we use every day. So Ribbit messages are public, kind of like Twitter. Ribbit messages are sortable by hashtag, kind of like Reddit. It allows discussion by common themes. Ribbit messages can be sent and retrieved over the air, so it feels like your 1990s built-in board system. And a unique feature is that Ribbit messages are grid square geocoded. Therefore, filtering message by local proximity is possible and highly advised. I will now talk about the future Ribbit system architecture once deployed. You can see in the bottom corner the coupling of smartphone and HTs through acoustic coupling or Bluetooth coupling. And you can see that cell phones are connected to cell towers on the backbone internet to the Ribbit cloud application. And on the analog side, HTs are connected to local repeaters. And on this local repeater, we actually running a local Ribbit server node. I will highlight the functions of these two parts. The Ribbit cloud application supervises the network health and status and statistics. It keeps tracks of message sent or received, but just the headers. It doesn't keep track of message content. It's there to give you a high-level view of the health of the system. The local Ribbit server is installed on the local repeater and continuously listens on the repeater for Ribbit messages. It stores about 1 year of message with 64 GB of storage on a Raspberry Pi. Anyone can request the last 50 messages by sending a request code. It's a sort of store on forward mechanism. And it's synchronized with other server in a redundant peer-to-peer message replication when the internet access is active, but it acts as a local node when the internet connectivity is down. In conclusion, where we are today, we have a robust implementation for digital text over analog audio, and we're still in the early stage of development. Our next step is to focus on RS group needs and user experience and feature to radically enhance their situational awareness and communication capabilities. This will be done in the Ribbit app. Later, we will focus on developing the cloud application server. If you have cloud development skills and want to join the project, please contact us. Demo app. Thank you for hanging out with us. Here's your free tech demo download. So try Ribbit today. You can download the following app. It's called Rattlegram, and it's on the Google Play Store. You can scan the QR code. Why is the app not called Ribbit? Well, we reserve the Ribbit name when the app will be ready for general release. This is only a tech demo, but that's enough for you to install on 2 smartphones and use your HTs through repeaters or in simplex mode, and you will be able to transmit text from one HT to the other and see for yourself the performance of our implementation. Thank you very much for your attention today. It's a pleasure to have you in this presentation. Get in touch if you have any feedback or you want to contribute to the project. We appreciate you getting to us. And I will join you on the other side for question and answers, beginning now. And don't forget to download your tech demo.
No.
No.
We will take questions now. I already see Michael K6GTE is asking what's the symbol rate. Symbol rate, because these are OFDM symbols, they take a long time, and it's around 180 milliseconds. So you have about 5 to 6 symbols per second. Yeah, you have been rickrolled. Dan Romanchik Key B6NU is asking, my Android phone doesn't have GPS. Will Ribbit still work on this phone? Yeah, please answer.
Yeah, I'll take this one. So I think all phones have a GPS receiver built in. I mean, only maybe even $20 or $30 entry-level phone have GPS in it. So you may not be aware, but if you click location on, you will have location calculation on your phone. Now, if it would be a phone that doesn't have GPS for privacy reason, what will happen is that your grid square geolocation will be degraded and the statistics of your connection will become loose. So if you activate your location in normal mode, it will actually start to show sort of a map of connectivity around a repeater and around your HT. So you start to know your range and how you get healthy connectivity through UHF or VHF. If you disable accurate location, then your grid square will default to unknown or a very large grid, and all these statistics will become junk. So you'll still be able to use the transmit function, but in an emergency, you want to broadcast where you are because the first responders need to be able to get to you. So that's why we got location in there.
Next question. Dan W9STS is asking when it will be available for iPhone. And I would say that it depends how many people are interested in this. And if somebody's starting to sponsor us, then we will pay the price that you have to pay to start developing iPhone apps. And then we will do that. But until then, I think it will be only Android limited for now.
The question is whether do you need internet or cloud, or can it work without?
Thank you.
I'll take this one. So the beauty of the implementation is that it's using the internet when it's available 99% of the time. And so what happened is that while you transmit message on Ribbit, you could actually not use your HT. And if you got cellular, it's going to sync. And the benefit of that is that it brings the feature set on parity with the user experience that people are used to on the cell phone. So you can go onto your local node and, for example, say, I've got stuff for sale. So you list all the gear that you don't need. And you got a new ham operator and say, let me look by proximity. What can I find for gear? Or I need to borrow a cable for a day or something like that. And it encouraged local face-to-face people to meet, actually. What happened is to keep your Ribbit profile active, it requires for RS operator to do one Ribbit packet transmission through HF, so through VHF, UHF, once per week when they do their, net control meetings. And for general people is to do it once per month. For as long as you send a message on the analog side once per month, you stay active on the system. And so the reason for that once per month analog thing is that we want to encourage people preparedness and operational skills to be up and ready. So that means your HT is in a state of charge that it's adequate. At least you have half a battery. And so in case of emergency, then you're ready. So that's the purpose behind it. Now, once you move to analog side, what you will see is that the transmission of message is going to take a few seconds. So like you type your message on the text of your cell phone, it's ready to send. There's two techniques. Either you're fairly in a room that's fairly silent, you can use Vox mode. So when you press send on your phone, it will open the squelch and transmit the message. The other technique is, I call it the fast finger, is pretty much like you press PTT and then you press send on the smartphone like a quarter second or half a second after. And that's also works just fine. And then the message will be sent, takes about a second and a half. And then if there is internet connectivity, your receipt acknowledgement will go through the cloud. So the Ribbit server or the simplex person that received your message on Ribbit, the header will go to the cloud application server and go back to the first cell phone, and then you'll get your acknowledge receipt check, kind of like on your text message that your text message has been transmitted. If the receiving station doesn't have internet connectivity, it will send you a Ribbit packet acknowledgement. And so you will receive within the next few seconds after you send your packet a chirp, and that Ribbit chirp will contain the header and the checksum to acknowledge that the entire message has been adequately received with the full decoding. So it works with and without. And the most important thing is that you promote an infrastructure that is exactly replicating the organization structure of ham radio hobby. So you have all ham operators, they can access the Ribbit app. There's zero barrier to entry because it's free. Everybody's got a smartphone and an HT. So we really foresee to have a very broad user base. And then we put the responsibility on radio clubs to upgrade their antenna with a repeater server, a Ribbit server. And what happened is that in normal times, you just have that kind of chat feature and message boards and knowledge base. But when the emergency comes up, then you really have, a full text messaging feature implementation that's ready to roll when the emergency comes. All right, thank you.
David has a couple of questions. The first one you already answered, which is it planned to be iOS also? The second one is, can it load on a Chrome notebook? And the third one is really interesting, which is, will the application automatically select routing, cell, or VHF, or does it do both?
I can ask. I already did answer the iOS question. It's the same like with the iPhone. If there are enough people interested and some money is streaming in, then we can pay all the upfront costs to develop iPhone applications, and then I will see no problem to have an iPhone app and also support it in the future. But at the moment, it's really just Android limited. And the second question was if it runs on a Chrome notebook. Since a few years now, it's possible to start Android apps on the Chrome notebook, but I haven't tested it yet. But I tested it for my older applications, and it works just fine. So I don't think that there will be a problem. So and also I can test it again. So if there's any problem, I will fix that, and then it will be no problem. So, and the last question. Maybe Pierre, you want to answer it?
Yeah.
So I explained the architecture, how it routes message between cell or VHF. So I will reiterate. If you, let's say, you've done your VHF packet transmission, Ribbit transmission, and you're a normal user, your credentials will be valid for a month. So for a month, you can text from anywhere on your cell phone on cellular connectivity without any VHF packet transmission. After 1 month, you'll start to see the prompt that will tell you you need to do a VHF packet to reactivate your credential. Now, it doesn't block you, but it actually will have a banner that stays there constantly until you do your VHF transmission. And what it is that now on the cloud server, we got statistics that shows the state of readiness of the entire ham radio population. So you say, how many have been connected through VHF in the last 7 days, and that's for emergency response teams. And then how many synced through VHF over the last 30 days or more. And we see these statistics going up and down, and that allows us to actually promote and do outreach, and then education through the cell phone apps that you need to connect, because in terms of emergency, you need to be ready. And practice makes perfect. So taking out your HT, transmitting some packets is a good thing to do. Now, it's not just transmitting some packets as as an upkeep or an effort. The thing that people don't see, and that's going to be something for a future presentation, is that Ribbit opens up tons of recreational capabilities. So start to think Summit on the air when somebody comes with a directional VHF antenna and collects Ribbit packets, and so transmit Ribbit's message down the valley to a maximum number of operators. Because the messages are geocoded, all the statistics of your QSOs are automatically logged in the app. So you got a very, very sleek user interface that allows you to do your activities. And we're looking forward to do an API connectivity to the on the air website, and likewise for Park on the Air. So you can start to do POTA, SOTA, Ribbit packets. You can also start sending Ribbit packets over AMSATs. And currently satellite pass, when you do your radio transmission, the voice, how long it takes to tell your your call sign and then get the acknowledgement and back takes about 10-12 seconds. You could actually have more packets go through the satellites and increase the bandwidth and capacity of the satellite transmission by just chirping, Ribbit message. So you could see that functionality evolve and really have your AMSAT passes forecasting the Ribbit message and only chirp the message when the satellite is exactly above you, for maximum and best transmission. So there's a lot of things that can be done on that new capability. And so we're very excited. Yeah.
Next question. I'm sorry.
Yeah, go for it.
So the next question is from Jeffrey. What method is used to determine when the RF channel is clear to transmit?
So that is your own ears. Same as with voice audio. So your own ears is when you send your packet. And if you didn't receive an acknowledge, that means they didn't went through and then you need to send it again. But today, when you go on the air, repeaters are, I wouldn't say silent, but there's a lot of open. It's clear. So we can send a lot of message before we'll saturate the system.
There was one question from Michael that hasn't been answered. Yeah, Michael asks, I just downloaded the app. Is the system connected to an internet server at this time? No, it's not. This it is really a tech demo only. It's not doing any connection to the internet, not licensing, nothing. So it's really just a free standalone app. And it's also not going to have any advertisements whatsoever. So this is really just a tech demo. Next question.
You got one just before from Douglas. The QR
code. I answered it. Yeah, if it's the same name as Ribbit, just as Pierre said, we haven't occupied the name Ribbit on the Android phone right now. We just chose Rattlegram. So there's a distinction between the tech demo and then later with the final result of Ribbit that we are going to use then for the networked version. So this is really just a tech demo.
Yep.
And it's for free.
Paul's got a great question. VE6ATS and M5ZD. Please expand explanation of Bluetooth interface on the HT side. So what we have today is we have HTs that haven't really progressed over the last 20 years. And I don't want to ruffle any feathers or like if you look at the recent release from major manufacturers, we're still having 7-segment display on HTs like they were 20 years ago. What's really overdue, and I would love to see it coming, and it's starting to come a little bit on the Chinese HT, is USB-C charging. I think is a must in a modern HT, because in case of emergency, you want to be able to streamline and simplify all charging smartphones and HTs on USB-C on an emergency battery bank. And the second feature that should come but hasn't fully come yet is Bluetooth, just regular audio Bluetooth, the Bluetooth you use to connect to the dashboard in your car, or the Bluetooth earpieces that we had 15 years ago. So that regular Bluetooth, when it will become mainstream, on HTs. We will be able, and we are able today, to pair your cell phone through your HT through a regular audio Bluetooth. And what happens here, and Amit can explain as well, is what happened is it's an audio stream that is in the analog domain, and then it gets redigitally encoded on the Bluetooth frames transmission to the next device. And what we have is, because we encoded digital text on analog audio, we got digital text re-encoded over digital Bluetooth compression. And Amit spent significant work, and his experience is that the encoding that we use survives the transcoding and compression of the Bluetooth algorithm. And that will allow us to, when HT that have Bluetooth are more prevalent and more mainstream, to eliminate the audio coupling and have that synchronization on the Bluetooth side. Amit, you want to talk about your test on your car dashboard Bluetooth, maybe?
Yeah, I tested it over my infotainment system on the BMW, and I didn't see any problems, no distortion whatsoever. It just worked out of box. And also with Bluetooth, it depends on what mode you are using. So the audio is either compressed or it's not compressed, but it has a very low sample rate and a low sample resolution. And then you have really no problem transmitting over Bluetooth any data packets that are created from this Rattlegram or Ribbit application. And also on the other way around, if the infotainment system is sending you the Bluetooth over the loudspeakers, you can just receive it with your Android phone, and it just works fine. And it looks also, it is so clean that you can do even a higher data rates. So I don't know if we are interested in this in the future, but right now we are interested in a very robust transmission, so it survives long distances and also more noise. I mean, in ideal conditions, you can do much more, but I don't think that is going to happen when we are really struggling to send something out and receive it. So we want something that is robust.
Yeah, and so we target the lowest common denominator. So in the Bluetooth encoding stack, you got some modes that have been existing from the very first day of Bluetooth, and then you got some high bandwidth modes that are more, I would say, high definition audio maybe. We're really targeting the lowest common denominator. So I'm talking about the cheapest Bluetooth chip that's been around forever and your worst implementation of Bluetooth. That's what we are targeting as the test, so that it can really work with every single Bluetooth device out there.
Next question.
I think that's about the questions. Many of them have commented that this is really cool and that they will download and try things out. Interesting use of existing hardware. So yeah, that they said it's a novel idea. Yep.
I think we have one from David about local clubs. So David K04 USA. Nice call sign, David. Great work. You guys should also start meeting the rounds to local clubs. This will significantly spur adoption. Is this something you would consider? So yeah, this is exactly our roadmap. So I am in contact with my local ham clubs here in Atlanta. And what I want to do is first explain what is Ribbit, and then start to really take into account the tremendous experience and live experience on emergency response, preparedness, and also all the exercise that they do every year on the preparedness of responders, and start to get this feedback as input on how to optimize the user experience on the app so that it really is of use for first responders. So we're gonna get them as VIPs to get into their requirements, and then I hope soon we'll be able to have a local ARIS group here in Atlanta start to use Ribbit for their weekly net meeting. And the way I see it is that usually a net meeting is at the top of the hour or 30 minutes past the hour. So what will happen is we'll call it the 5-minute Ribbit, which is the 5 minute prior. So 5 minutes prior to meeting, everybody can chirp their Ribbit message. And when the net meeting starts, the net control operator can say, we already received the check-ins from all of these packets, and you'll have call sign and location. So call sign XYZ from location city. And then anyone else that's on analog, please come in now. And what happened is you've just fast-tracked the net control meeting to be much faster, and the net control operator starts to have statistics, so he starts to see, on table form and a histogram, who's repeating a call sign that came every week, which ones are missing, and then you start to see the health of your net. And this is the type of tools that we want to equip them. And that's going to be the first phase. And then after that, we'll expand to a second group, which is local first responders. And so you have people in the state of Georgia or in the county that are in charge also to coordinate, net controls, coordinate emergencies. And then we'll help them say, how can we interoperate, with your equipment, that flow of information. So that's going to be another focus. So Michael WH6ZZ is asking for a URL for more info. So if you go around the expo, you will find the Open Research Institute booth, and you'll see the Ribbit. When you click on the Ribbit on the booth expo, it'll direct you to GitHub, and you will be in the GitHub of Open Research Institute on the Ribbit project, and this is where we have our public webpage. It's our GitHub README first page. All right. Clifford, N0LKC, totally makes sense with Bluetooth. Too bad we are so far behind the times here. Well, I think that if the Chinese come with a USB-C charging on their HT, they're giving everyone an opportunity to upgrade once. And in a few years, they come with Bluetooth, they'll give everyone an opportunity to upgrade twice. So that'll be a very good commercial sense from them if they bring these features forward. All right, so Ron, NR5ON. I've noticed that some HT only support the audio from a headset type connection and will not pass audio from a phone type connection. Is it possible to make the phone look like a headset over Bluetooth in order to pass audio? Yeah, it really depends on the implementation of your specific HT. One thing that I know, I have it here. I have a BTEC cable that's designed for APRS. And what we have on this cable from BTEC, it's a contact for your phone, which has headphones and microphone. And then it has the typical Kenwood connector that goes on every HT that's equipped with Kenwood connector. And in the middle here, you got some analog resistors to normalize the levels, so that the levels that come out of the phone audio to the HT. So this would be perfect type of equipment for, let's say, the emergency response equipment. They could go up a hill with their HT, and then they would operate a Ribbit server, and that would be quality of life improvements for transmission. But that's not an equipment that we expect, regular ham radio operator to buy, because, if they just send a few message here and there, and you would be surprised, the ergonomics is really good. You just, tap on your phone, press PTT, press the phone screen, and it just goes. So this is not a requirement. Michael, KM5BOR, is it possible to send this over Arden Mesh or other systems? So I think once you start to have text messages, you have the data. So interconnecting it to other systems, it becomes feasible. The problem that we had with voice is that voice is a high bandwidth mode. You have to have full voice recording. You would need to have message transcription, so voice is transcoded into text, and there would be some errors in the transcript. And today with AI, you can do voice to text, but here it's native text. So you could push it to APRS, but you would probably crash their bandwidth. So, all right, I think we're reaching the end of the questions. Thank you very much, everyone.
Thank you.
Thank you, Vidya, for the moderation.
Pleasure.
All right, and so I will be hanging out in the ORI booth on Kumo Space for the next half an hour. So if there's any of you guys who want to chat or have further questions that don't go on the recording, I'll be there to exchange and mingle for the next half an hour or so, or longer if there's more people. All right, thank you, everyone.